Hi everyone. Let's start with the next section, Acting like a Typewriter and File Explorer. This section is all about limiting data, utilizing it, modifying it, internationalizing it, replacing it, and even searching for it in the first place. We will begin with the first video that deals with striping, altering, sorting, deleting, and searching strings with bash only. While we can easily use grep and sed commands together, sed by itself, or even using another very useful command called awk, we can leverage bash itself to save time and reduce external dependencies in a portable way. Let's begin with a few examples. For that, we need to create a new script file and name it as script.sh and add the script content into it. As you can see, we have already created the script.sh file. We will directly add the code snippet into it and understand the code in detail. Here we can see a special way of calling special substring functionality, as you can see the syntax in the highlighted part of the code, where variable is a string variable within your script, or even global, and then the following variable is the colon. After the colon, there is the starting position parameter. Remember that strings are just arrays of characters and each character can be addressed by index. In our case it is 3, and there is another optional colon and length parameter, optional length, and the value is 4. Save this file and get back to the terminal. On executing this script, the output would be test as displayed on the screen. How is this possible, you may ask? Well, it's possible with bash's equivalent of substr, a function in C and many other programming languages. And this is achieved through the user of this syntax. This tells bash to look inside for a variable named variable, and then for two parameters. To start at byte or character 3, technically 4 because array start at element 0 in bash, and a length of 4, to print only 4 characters. The result of the echo is test. Great. Can we do more with this, such as removing the last character, deleting words, searching? Of course, and all of this is covered further in this video. Let's get ready for the exercise by creating some datasets which mimic common daily problems. First, we will create a test data directory, and then we will create a garbage.csv file containing a few text data. Then, in the garbage.csv file, we will add more text data. Post that, with continues3 command, we will add some data in the employee.csv file. Using these two CSV files, we are going to perform certain tasks. First, we will remove the extra spaces on the first 2 lines of garbage.csv. Then remove the last character from each line in garbage.csv. Change the case of each character to uppercase in the first 2 lines of garbage.csv. Post that, we will replace Bob with Robert in employees.csv. And insert a hash at the beginning of each line in employees.csv. Also remove the exact date of birth column or field in each line of employees.csv. As we are ready, let's begin our activity. First, open your favorite code editor and create a new file. As you can see, we have already created the built-in -str.sh file and add this block of content into the new script. Save it and let's understand the code in detail. Let's play with variable arrays first using bash's equivalent of substr. With this line of code, we will begin with string declaration. In the first step, we will print out a single character starting at the 0 position. Remember that this is an array, and position 0 is the starting element. Next, we retrieved the first 3 characters to arrive at, 1, 2, 3. However, what if we wanted all of the characters after position 3? We would use this syntax. As given the previous point, if we wanted the characters at position 4, the 4th element in the array, but this is addressed at position 3 because counting begins at 0, we will use this syntax. And finally, to get only the last character, we will use this syntax. Can we compare the alphabeticalness of strings? In this part of the code, we can see, to finish the first script, we had 3 more strings. If we wished to compare them to each other, we can do so using conditional logic. remember that BCD is less than BCD. As you can see here, we have implemented in this example. Let's navigate to the terminal to execute the script builtin-str.sh using bash command. Here, the output is generated successfully. We can notice how we were able to strip the last character from a string and even compare strings. Again, go back to the code editor and open a new file called builtin-strng.sh. As you can see, we have the file already open. We will add the related code snippet here and try to understand the code in detail. In the first step, we will use read in the garbage.csv and then use this syntax to retrieve the number of elements in the array. We don't use this value, but it is interesting to note the structure of your file and whether it is being read correctly. Then, in this part, we will out of the last lines in the CSV called garbage.csv file. Notice the for loop. There is a caveat. Here, with these two lines, we will check how many rows do we have. In this part of the code, we will strip the garbage, that is, remove spaces. To learn more in detail, for each member of the array, we remove the empty spaces by counting the number of spaces and then removing them with an additional while loop, performing this function until we're done. The corrected values are then reinserted into the array. Post that, we will remove the last character from each line. In this step, we will use this syntax and a for loop to remove the last character from each line. Then the result is reinserted into the array. Now, let's turn all the characters into uppercase. As you can observe in this part of the code, using a for loop and this syntax, all characters in the array are made uppercase, and we print out the array using printf. In employees.csv, we will update the first field to be prepended with a hash character in this part of the code. Onto employees.csv, we will read it into the array again using readArray. Then we add a hash sign to the beginning of each line and reinsert it into the array as done in the highlighted part of the code. In the next part, Bob had a name change. He wants to go by the name of Robert. Replace it. So, using this code part, we will search for the substring Bob and replace it with this syntax. To use the built-in search and replace functionality, we will use the syntax with respect to the highlighted part on the screen. The code related to the replace functionality is displayed in the overlay. Further, we will look at the final part that is implemented in this part of the code file. The final step is a bit more complicated and a bit long in the tooth, meaning it could be shortened and performed using another tool such as AWK. But for the purpose of an easy-to-read example, it was written a bit like a C program. Here we want to remove the actual birthday value, that is 0 to 31, or column 5. To begin, we iterate through the array using a for loop, and then we use read to take the input value as an array too. Then, for each field in this array, we will then check to see if it is not the first value and also not the column we wish to remove. We build the correct string via concatenation and then reinsert it into the array before printing each value using echo, as we have implemented in this part of the code. Let's save this file and navigate back to the terminal. Execute the builtin-strng.sh script file using the bash command and review the output. We have successfully managed to generate the desired and appropriate output. That's all for this video.